Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yeah, so hello everyone. Good evening. So, those who are present in this session, can you please write your name in the chat box? Uh, Today will be a practice session on graphs and trees. So, let me change the layout. And yeah, so hello Srinivas, how are you? Your name is Shrinu, okay? Is Naika here and other people who used to regularly come to the session? There will be a practice session on tree and graphs. Okay, so let's begin then. Yeah, or should we wait a couple of minutes for other people to join? Hello, Ashu Sana. Yeah. Okay, I see quite a new people. So, is this your first time you're attending this session, or have you previously attended? You can write in the chat box. Okay, Srinivas, first time. Okay, so I see a lot of people are here for the first time. So, first of all, I would request everyone to kindly stay with me till the very end. This session won't be very long, at max 40 minutes or so, or maybe 35 minutes. So, in this session, we will be discussing two very important problems. One will be based on graph, and the other will be based on tree. So, this session basically started in the month of December, and in the entire month of December, we studied about graphs, and in the month of January, we focused majorly upon trees. But since both of those are complete, we will be focusing majorly on practice problems. So these problems are extremely important from interview point of view. So I would request you all to kindly listen to it and try to solve on your own as well. Okay. So let me paste the link of this Jamboard slides in the chat box so that you can refer alongside me. Yeah. And one more, there is another announcement from the side of Geeks for Geeks, which is that, as you all know, that Geeks for Geeks regularly conduct mock interview sessions, which was basically mock live DSA. So that was usually streamed on the Geeks for Geeks YouTube channel, but this has been rebranded and it will be streamed on the GFG Practice channel. And this will be a practice interview. If you want to give a mock interview to the mentors at Geeks for Geeks, you can just fill up the form in the description. Okay, and every Saturday we will be having that mock interview. Okay, so you can have a look at that as well. So because it will certainly be helpful in your interview preparation as well, because the more the number of mock interviews you give, it will be very helpful to you all. So a quick recap about our previous sessions is that we studied majorly everything about tree. We studied about the in-order traversal, pre-order, post-order, all kind of traversal. Then we studied about binary trees, binary search trees also, the definition of binary search trees, how to find like other problems as well, how to find a seal of a binary search tree, how to find a floor, and then how to insert a node in a binary search tree, how to find a node in a binary search tree. So all these were also there. So these are the topics that we've already covered. So today will be majorly practice of two questions only. So let's look into the first question then. So the first question is based upon tree. Okay. So this is based upon tree, and the second question is based upon graph. Okay. So both of these questions are medium to hard level questions, and you can expect to be a bit tough. Okay. Okay. Hello. How are you? So I see 8 people with me live right now. So can you kindly write your names in the chat box so that it becomes very easy for me to follow, and at the same time to make keep the session interactive. So yeah, let's first of all try to know about yeah. So does anyone know what exactly do you mean by children sum property? Anyone? Hello, Srinivas. Hello, Ashu. Do you know about the children sum property of a binary tree, or are you hearing it for the very first time? Yeah, so I would request everyone to keep the session bit interactive so that this will also motivate me to provide you all great content, and at the same time, you all will also learn. Okay, so first time. Okay, Ashu is you are listening for the first time. Okay, so yeah, so Ashu, do you have a understanding about binary trees, or are you like do you have basic knowledge of binary trees because it will be easier for you to follow in this case? Okay. So let's see then. So can you all write your names of the colleges you are presently in and the year in which you are studying? And are you trying to secure an internship or a placement in your upcoming season? If that is the case, uh, you can write the same in the chat box. That would be helpful. Okay, you have basic knowledge. Okay. Okay, then that's great. Basic knowledge would work. What you can do, you may not understand entirely, but you will just try to get the definition. So, in children's and property, basically, I have just written it in short form, CSP. It's not like that, it's called CSP. So, what happens here is that every node will satisfy this condition. The condition is that the value of the node will be equal to the value of its left child plus the value of the right child. If this condition is getting satisfied for all the nodes, then we can say that tree is following this property. And if it doesn't, then we will say that tree doesn't follow this property. Okay, so let's see this tree. If I see, is this tree following the children's sum property? Yes or no? Can anyone tell? The property is that this equation must be satisfied. That the value of a given node should be equal to the value, sum of the value of the left node plus the sum of the value of the right node. So see, the value of this node is 2 and the value of its left children is 35 and 10. So the sum of these two values is nothing but equal to 45. So but the value of node is not equal to 45. So we will say that this tree is not following this property. But let us say that if I am making this the node the value of the node is 45. In that case, I can say that 35 plus 10 is equal to 45, and 30 plus 5 is equal to 35. 8 plus 2 is equal to 10. So I see that this property is getting satisfied for each and every node of the binary tree. So therefore, we can say that the second tree, the tree on my right, is basically following the children's sum property. Okay, so this tree is following the children's sum property. So this is the question. This is the concept about what is children's sum property. But what exactly do we have to solve? Let's see. So there are two types of question that can come from children's sum property. Okay, so let's see what is there in Geeks for Geeks. Okay, so an easier version of the problem is present in the GFG. Okay, so the easier version of the problem says that you have to only check whether it is a binary tree, means whether the tree is following a children's sum property or not. So okay, you just have to check whether the condition is getting satisfied or not. So this is a easier version of the problem. But again, there is a tougher version of this problem which says that you have to basically convert a given tree to another tree. So So if the tree is not satisfying the children's sum property, you have to convert this tree into such a tree that it is satisfying. But the only condition here is that you are allowed to only increment the value of the node and not decrease. For example, the value at the root node was 2 and the sum of its children was 45. So I incremented the value of the root from 2 to 45. Okay, now I see that the value of 2 and 3 are equal to 5, but I can individually increment both the values. So the idea is that if a tree is not following the children's sum property, you are only allowed to increment the node value and nothing else, and not decrement. Okay, so this was the tougher version of the problem. Okay, so any doubts still here? Hello, Naikash. Are you? That's great. You're coming. So, Naikash, we were trying to understand the children's sum property of a binary tree. I'm sure you know about this. Yeah. So, yeah. So, basically, let me just recap for Naikash. So, the children's sum property states that the all the nodes of our binary tree should satisfy this equation. Is that the value of the node should be equal to the value of the left children plus the value of the right children. Okay, so if this is getting satisfied, then we can say that this will work. But now let's see that, hmm, yeah. So the two types of question that can come. So the first question was this. So let me just tell you one thing. Okay. Yeah. Okay. So this was a question. Yeah, no, 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 not exactly balance tree. Uh, the idea is that the link which I just pasted, the GFG link, this is basically the easier version of the problem. The problem is that you have to just say yes or no. So whether it is following the children's sum property or not. So this becomes very easy. Let me show you how. So all you have to do is write a recursive code for the same. So by the recursive code, I means that you take the left data and take the right data, and you add both. You declare two variables. So what you do if the left and right are not null, means that there are valid node present in both the left and both the right. You take the sum. Okay, so you take the sum, and after you take the sum, what you do, you check whether the node data is equal to the data or not. So if it is equal, it means that for that node, the children's sum property is getting satisfied. But that is not the remaining condition. Now this condition should get satisfied for each and every node. So what will happen now? You recursively call the function for the left children as well as for the right children. So this is what it is happening. You check whether it is equal or not. If it is equal, that condition is getting satisfied for the root node. But now it's time for it to get satisfied for both the left and the right children. So that is here when you are calling recursively. So if all these three conditions become true, it means that the root is also satisfying, the left child is also satisfying, and the right child is also satisfying. In that case, you can return 1. It means yes, the entire tree is satisfying the condition. If not, you return 0, which means that at least one of the nodes did not satisfy this condition. So this problem is marked easy. Hmm. So as you can see, all the test cases have passed. So this problem is marked easy for a reason because hmm. So because see, you just have to say yes or no. So, but the tougher version of this problem is that if I say you that you have to convert, if the tree is not satisfying this property, you have to convert this tree into a tree which will satisfy this property. But the only condition here is that you can only increment the value of the nodes and not decrease it in any way. So how will you solve this problem? This is actually a hard problem. Okay, so any ideas here? Let's see the chat box. Naikach, do you have any ideas about how we can solve the problem? So let me give you a small example. So let's say you see the root node is 50 and the sum of the children is 7 plus 2 9. So if I want to make the root node satisfy equal to the 7 plus 2 9, I am supposed to decrease the value of root node. Okay, but I am not allowed to do so. So is it possible to convert this tree into another tree which is satisfying these children's sum property for all the nodes? Okay, so that is a concept. Okay, so let me say that I do something like this. I put a 50 here, which is the root. I again put a 50 here. I again put a 50 here. So it means that I incremented 7 to 50 and 2 to 50. Now I again find the sum. So sum is equal to 3 plus 5, which is less than this number. So I make this equal to 50 and I again make this equal to 50. Same thing will go for this is 31. So 31 is again less than 50. So I will make this 50. I will make this 50. So I incremented all the values to 50. Now what will I do? I will just move back. So I see 50 plus 50 is equal to 100. So I will increment this value to 100 and I will also increment this value to 100. After that I see that 100 plus 200 is 200 and I will increment this value to 200. So finally, our tree is looking something like this, and this tree is actually satisfying the children's sum property. So, did you see the algorithm which I used? So, any doubts here? Michael, what are you trying to say, like balanced tree, which I am not able to understand your doubt? Yeah. So actually, we do not have the harder version of this problem on Geeks for Geeks, but you can find that in other platforms, maybe on LeetCode or something. So, how to solve this problem? Any ideas? Okay, yeah. So I just described you the way you can actually solve this problem. So let me just revise the algorithm once again. Let's say you are standing on the root and you see the value of the root, which is 40. Then you come down to the left and right. You see the value of root is equal to 30. So the children's sum is 30. So 30 is less than 40. If the sum of the children is less than the root, then what you will do, you will replace each and every children with the value of the root node. So this will be equal to 10 will be replaced with 40, 20 will be replaced with 40. We will do the same for again other roots. So 2 plus 5 is equal to 7 and 7 is less than 40. So we'll replace these two values with 40. Hmm. But when you come here, you see that 40 plus 30 is 70, but 70 is actually greater than 40. So do you know what you will do in that case? In that case, you will increment this value. Okay, so 40 plus 30 is 70. So you will increment, this was 40. So 70 was greater than 40. So what you will do, you will increment the parent. So if the sum of the children is less than the parent, you will increment the children. But if the sum of the children is less than the parent, you will increment the parent. Okay, so this is how the algorithm will proceed, and the 20 will become 40 in this case. Again, you traverse back and mm, bring a result for the same as well. Yeah. Naikas, are you there? Yeah. So. Yeah. So let me just put up an implementation of the same problem. Give me a minute. In fact, this algorithm is also a recursive algorithm. So let me just paste this. So I will be just pasting away the copy here because we do not have a problem of this problem on GFG platform. So I'm just putting up the implementation here itself. Okay. So this will be the implementation of what I just described. Hmm. So the first thing would be to check whether it is a null or not. Okay, so if it is null, in that case we return. Then we declare a variable called int_child, initialize it with 0. The first thing we have to check whether the left is valid or not. So if the left children is valid, we add the data in child. If right is valid, we again add the data in the child. Now we will check whether the value of the children, the sum of the children, is less than the value of the root, okay, or the value of the root data. So if it is less, we replace the children, right? So what we will do, we will replace the children, the left children and the right children with the data. Okay, after we do this, we will recursively call for the left and the right. Okay, now if this is done, now what will happen is that we are recursively going down the tree path. Now, if let's say if there was a case when the sum of the children was greater than the value of the root, in that case we are supposed to change the root. But we will not change when we are going down the recursion, but instead when we are coming up back, in that case we will change. So now what we will do, we'll declare a variable called total. We will do total plus left data, total plus right data. And if the and if basically if we are coming here, it means that we are supposed to replace the root with the total. Okay, so if the root is greater than the sum of the children, in that case, in fact, if the root is less than the sum of the children, in that case, we replace the root with the sum of the children. And if the sum of the children is greater, we replace the sum of the children with the root. So this is how the thing will work. So whenever we are going down the recursion, we will increase the children's, and whenever we are going up the recursion, we will increase the value of the parents. Okay, so this is how this algorithm will work. The best part about this algorithm is that this works in linear time over n, because we are doing a recursion and all the nodes are getting visited only once. Okay, so but you will find a similar article on GFG as well, but that is actually a O of n square article. So this is a much better optimized version of the same. So let me just keep uh, convert tree to children some property, or in fact children some property. Let's see. Any doubts here? Yeah. So you have this article for just checking, but in fact, I saw it previously that if you want to convert a given tree to a tree which is for satisfying the children sum property, you can only do that if an O of n square approach, but this approach is taking O of n. Now, why it is O of n? Because in the question it is not mentioned that you are supposed to minimize the value of the every node. Okay, so what I'm doing in this algorithm is I'm trying to just randomly allot any value, maximizing each and every value, whatever it may be possible, so that I can get a valid tree. Doesn't matter, no condition, no restrictions on the values assigned. So this is what I'm utilizing to bring down the complexity to O of n. Okay. Yeah, so Naika, are you here? Yeah, we have 6 people with me right now. So those who have joined a bit late, can you please write your name in the chat box? Yeah, so I have pasted the link of the problem on the chat box. So yeah, this is again another hard level question. Yeah. So meanwhile, those who are have joined new, I would like to inform you that there is something called live mock DSA at Geeks for Geeks, so that you can basically get your mock interview done from one of the mentors at Geeks for Geeks. So this will be on this practice channel itself, and it will be on every Saturday, I suppose. You can find the details in the chat description. Yeah, yeah. Hello, Naikaj. Hello, Ashu, and hello, Srinivas. So, any doubts in the previous question, or should we just suppose move to the next question? Yeah. So let us see this question. So in this question, what is happening that you are given a graph. So you are given a graph. So this graph consists of n nodes. So it is the nodes are numbered from 0 to n-1, and these nodes are bidirectional in nature, which means that it is an undirected graph. The thing is that you are given a 2D integer array where you are given that an integer array will consist of three values: the u, v, and time. So u, v, and time means that there is a edge between the node number u to node number v, and the time means basically the time it will take to traverse from u to v. Okay, you can see this vector. So so the vector consists of three numbers. The first and the second number are the node numbers, that is at index 0 and index 1. And the third index, at the index number 2, we have the time. The time it will take to traverse from U to V. Okay, so you have to tell me the shortest amount of time. The question is involving you have to tell how many ways are there you can travel from the intersection number 0, that is the node number 0, to the node number n minus 1 in the shortest amount of time. Okay, so let's say I tell you that you can travel from node number 0 to node number n minus 1 in time x, which happens to be the shortest time. But the question is asking in how many ways you can traverse from 0 to n minus 1 in x time. Okay, so you are not supposed to answer the shortest time that you will take, but you are supposed to answer in how many ways you can travel from 0 to n minus 1 in shortest amount of time. Okay, so the question is asking in how many ways. So if the question was that you have to find the shortest amount of time, you can simply apply the Dijkstra's algorithm. But in this question, you are asked to find the number of ways as well. So here you have to do a bit of modification with the Dijkstra's algorithm, and you will get your answer. Okay, so let's see this algorithm in practice. Yeah, so I don't see any doubts in the chat box. I would request everyone to kindly keep this session interactive. Okay, so that will be really great for me as well and for you all as well. Yeah. So basically, let us say that this is your final. Let us say that this is your final node that you want to reach, but in fact you see that there is a one path which is taking time x, there is another path which is again taking time x. So in total there are four paths which is leading to the final destination, and you're taking time x. So all these are four edges. So will your answer be equal to 4? Okay, so if you say that your answer will be equal to 4 just by looking at the number of edges which is taking x amount of time to reach the destination, in that case you will get a wrong answer, because even if this you seem to see that this is only one edge, so there can be multiple edges before this edge. So what is happening here, the number of ways to reach the final destination will be equal to the number of ways you reach node number 1, the number of ways you reach the node number 2, plus the number of ways you reach the node number 3, and all. So if in case there are four edges that are reaching the destination, you have to find the number of ways in which you reach this node. So it may happen that you reach this node in two ways. So you will not count this as one. Instead, you will count this as two. Okay, so this is the fallacy here. You have to think in this way. So that is the place where Dijkstra's algorithm will be coming into place. So, if you recall correctly, the Dijkstra's algorithm was using a priority queue and a distance array. Okay, so we had a directed graph. In case of Dijkstra, we had different nodes, and every edge had a weight. So we were using a priority queue. So I won't be repeating the exact concept of Dijkstra's algorithm, but you can get it is quite similar to that. So we were also maintaining a distance array. So this distance array was keeping track of the amount of distances covered, and whatever distance would be minimum, this is of type min heap. Okay, so minimum distance would be processed first. So I will also maintain another array called ways array. So this array will count the number of ways I am basically taking to reach a particular node. Okay, so for 0 I will mark 1. So let's say if I am reaching the node number 1, I will mark 1 because I am taking one way to reach here. Node 2 will be also marked 1. Node 3 will be also marked 1. Node 4 will be also marked 1. But let's talk about 6. So 6 can be reached from 3 as well as from 4. Okay, it may happen that both will require different times. Okay, so but our ways will keep account the number of ways I'm reaching 6. Similarly, for number of ways I'm reaching 5 in 3 ways. Okay, so these are 3 ways, but I can reach 5 in this, I can reach 5 in this, I can reach 5 in this. So there are 3 ways. Now from 5 I can also reach 8 as well. So the thing here is that you can reach 8 here in 1, 2, 3 ways you can reach 8 here. So the answer would be 3 because number of ways to reach 8 from here. Again, this is also another way to reach our destination 8. This is also another way to reach our destination 8. So what this ways array is doing, it is keeping track of the number of ways you are getting to reach a particular node in the particular least amount of time. Okay, so all we have to do is get this node done. Okay, so okay, someone is commenting something. Question is loss of significance. Example. Okay, hi Somesh. Hello Anmol. I would recommend you to kindly keep your doubts relevant to the session. Hello Somesh, welcome. So yeah, so I suppose everyone has understood the question that I'm trying to say. So this question, the implementation of this question would be given to you all as a homework. So I'm including the link of this question in the slides. Okay. So I've already given you the hint that this will be following Dijkstra's algorithm. Okay, so let me just mention it in the chat. So this link is already mentioned in the chat box, and I've already also mentioning it in the slides as well. Okay, so all you have to do is utilize the concept of Dijkstra's algorithm, but at the same time make a ways array as well. So this ways array will keep track of the number of ways in which you can reach a particular node, okay, and in a given amount of time. So finally, your answer will be in the very last index. Okay, so your answer will be stored here. The number of ways you are taking to reach the node number 8. So if you process this code, you will get a correct output in that case. Okay, so the implementation of this algorithm is left to you as an homework. We will take up this question in the next session maybe, and we'll discuss the solution then. Okay, so I would like to keep this session short because this we will be having very frequent practice sessions twice a week. Okay, so any doubts still here? We discussed two problems today. The first was about the children sum property of the problem of a binary tree, and after that we discussed about an implementation of the Dijkstra's algorithm. But the coding part is left to you as an exercise. I am sure you all will complete it. That is quite a good level of question. Okay, so those who are new in this session, can you all please like this streaming? I see many people haven't liked it yet. And kindly subscribe to our channel as well, because in the future we will be uploading great quality content on this channel. So let me just recap to you all the dates of these sessions. So on every Monday and Tuesdays, so on every Mondays and Tuesdays, we will be having a practice session on graphs and trees. Okay, so every Mondays and Tuesdays, we will be having a practice session on graphs and trees at 10 p.m. obviously. And you can also check out the dynamic programming series that is going on this channel every Thursday and Friday. Okay, this is also at 10 p.m. So both graphs and trees and dynamic programming are in itself extremely important topics for interview preparations. So this certainly will help you. Okay, so in case if you do not have any doubts, so let us kindly wrap up this today's session. Okay, so let's see how many of you. So Anmol, what exactly were you trying to ask? You can ask now since we are end of our session. Hello, Somesh Kundi. Did you like this session? Hello, Naikas, are you there? I haven't heard from you since a long time. So yeah. So I would request everyone to kindly join tomorrow's session as well. Yeah, I have already pasted the link of this. Let me just paste it again. Yeah, the slides link will be available. I have already pasted the link of the slide in the chat box, and I will also update it in the description as well. So you can refer to the slides. A very good night to all of you.
ওয়েব থেকে কিছু